Okay, so let's talk determinants. Let's start with our big idea. The Bermuda Triangle is an area located off the southeastern Atlantic coast of the United States that is noted for high incidence of unexplained losses of ships, small boats, and aircraft. Using the coordinates of the vertices of this triangle, you can find the value of a determinant to approximate the area of a triangle. So, kind of a trick, right? You can use, to find the area of a triangle, you can use matrices. Okay, and we'll do that at the very end. Do you guys see the connection here? AB, AB, CD, CD, EF, EF. I'm not going to go through the whole complicated derivation, but it breaks down to that. When you've got, because look, you've got 3 different points, but it needs to be a square matrix in order to be able to perform the determinant. Therefore, 1's go in those places, right? Because I mean, something times itself is 1, I'm guessing. Okay. You can't put zeros there because that would mess everything up. Alrighty. So second order determinant. Find the value of the determinant. The determinant. What do determinants determine again? What could I find? The area. What do we normally do when we have area? We multiply our base times our height, right? Okay. So the way this works is I'm going to multiply my diagonals and find their difference. So 6 times 0 minus green, red. 4 times 1. Sorry, 4 times negative 1 equals 0 minus 4 times negative 1 is negative 4, and this makes it positive. So I just get 4. You guys try one. You guys. Okay, so you should have gotten A times D is 3 times 0 minus 2 times 1. Well, does it ever stay that easy? Makes, should I change my color? 0 minus 2, which is negative 2. Question. All right, let's step it up a notch. Okay, as soon as all the complaining can stop, these are called third order determinants. Okay, so what happens is, if I want to concentrate on A, that means I take my row and my column, I said that backwards, my row and my column, I cancel them out, and I'm left with that right there. Okay? B leaves me with DGFI. C leaves me with DGEH. So what that looks like, let me take pictures of each one of them. So I can't take a picture of this one. Oh, we'll just go side by side. Alright, so this one goes here, and this one goes here, and this one goes here. And what I would do is I would put the A on the outside, this one I would put the B on the outside. Then it's not a multiplication matrix, it's a determinant. And I want to say that, exactly, you need, grouping symbols matter. Grouping symbols matter. When you have grouping symbols, order of operations, are you allowed to multiply first? You got to make sure everything on the inside is done first, right? So you can't multiply A until all of this is taken care of, which is, this is a second order determinant, right? You have to watch what I do. Just give me a second. It doesn't make much sense until I just do it. All right, so then if I put it all together, I would take this, then subtract, because it goes addition, subtraction, right? It is alternating. And then add this one. And now it's nice and pretty. Okay, go ahead and write that down. Okay, so evaluate using expansion by minors. That's what this is. This is expansion by minors. Minors being that these are the minors, we're expanding each one. Does that make sense? Expanding it into two order determinants and then breaking them down and working on them. No questions yet. Just let me do this. Okay? I'm going to erase this. You guys aren't going to write this one down. Okay? You're going to do the next one. So just give me your absolute attention. If you're doing this, right, are you really paying attention? Are you getting it all in? No. Okay, so just watch, because I'm going to use the magic of my technology. All right? Because this will make it a lot easier. So I'm going to shrink this down and then copy it. So now I have 3 of them. Okay, and so if I wanted to, if I was concentrating on this one, the 1, then I would need these. And then the 0 would be these. And the 1 would be these. Because I cross off that row, the associated row and column, the associated row and column, the associated row and column. See that? Evan, let me finish. So this is 1 minus, what is this, 0? Plus, is this a 1? Just want to make sure. -1. All right, so here I go. 1 times -1 times -3 is +3. -2 times 3 is -6. A negative and a negative is a positive. Minus 0 times, I really don't have to do this one because 0 times anything is going to be 0. But I'll do it anyways. 2 times -3 is -6. Minus 4 times 3 is 12. Plus -1, so it's kind of, it is -1. Times 2 times -2 is -4. Minus 4 times -1 is -4. -4. Okay, follow me so far? Yeah. Wait, no. 6 plus 3 is 9. 9 times 1 is 9. Minus 0. This is also a 0 times 1 makes 0. So my answer is 9. Now questions. Evan first. Yes. always. Yes. I'm doing the diagonals just like the other one we did. I'm finding the difference between the diagonals. Yeah. Because it was subtraction.
So, whatever you start with, you go the opposite of the next one. Like, say, like the one is positive, so it's like the next one will be negative, and the next one will be positive.
That's what this was. Positive, negative, positive.
So does it start with a negative?
That doesn't matter.
But inside the parentheses also?
Inside the parentheses, if you have a negative times a negative, that makes a positive. This should have been 4 minus negative 4. But I didn't want to put that many parentheses in there. Make sense? That was a good question. So let's say this is a negative 1 right here. It would start with negative 1. No. Has nothing to do with it. Does that make sense?
Because you're saying if the person's positive, then the next one's going to be negative.
No. It's positive, negative, positive, but depending on whatever this number is, that could turn it into a negative, and it could turn this one into a positive.
So there's no pattern.
There is a pattern. It's positive, negative, positive.
So we started with the negative.
Can I just show you the next one? Okay. See this one right here? See how it's always positive, negative, positive, but when I start, there's going to be a negative 3 out here. So that's going to turn that positive. I'm sorry, it's going to be negative then. You have to do it to understand it. You can't just, right? So here's an example of it. What I would do is I would use my, watch, I'm going to use my marker as a finger. I would say if I want negative 3, if I want the minor of negative 3, I'm going to put negative 3. It's a positive out in front, right? No matter what? Do you see that, Janelle? Positive, negative 3, which is negative 3. And if this was negative and this number was a negative 2, it would be negative 2, which would make the second order a positive now. The first is always a positive, negative, positive, but this number can make that change. Okay, so it's a negative 3, right? And then I would just erase with my finger. Uh-oh, wrong shape. I would erase this and this. And there it is right there. Make sense? Just use your fingers to like cover up the ones that are associated with that one. Or just, well, if you cross them off, then they're gone, unless you want to draw it 3 times like I did. Evan? Yes. All right, so you guys try. Okay, so after completing the process, you should have negative 71. Questions? Yes. I can't hear. It's never, 1 times 3 is 3 minus 4 times 2. That's the outside. It's always finding the difference between the diagonals, and difference is negative. It's always subtracting. Make sense? Alrighty. Okay, so now we're going to find the area of this triangle. So area equals half of base times height. Well, in order to find the area of a square matrix, right, I would take my base times height, or do this third order determinant. But I'm not finding a square, I'm finding a rectangle. I'm sorry, I'm finding a triangle, and a triangle is half of the base times height. So I'm going to cut it in half at the very end. Okay? So I would say, and literally at the very end. So it would be 1/2 times AB1. Well, it doesn't matter which one you do. You guys see that we're getting towards using determinate to solve a system of equations? Okay, don't freak out. 2x plus 3y equals 2. I could put that in the matrix 2, 3, 2. I'm not looking at this right now. I'm just giving you guys an example. Okay, so if this is my x, and this is my y, and this is my x, and this is my y, and this is my x, and this is my y, and I'm trying to solve something that involves all of them, does it matter which order I put them in? Order matters when you're multiplying matrices, but if I'm solving a system of equations, does it matter which order I put them in? No. What is solving a system of equations? What are we finding when we solve it? A coordinate where they all meet. So would it matter which one you put on the top, or which one you put second, or which one you put third? No, because you're all just finding a point where they meet, correct? Make sense? Okay. If you have one line and you have another line, does it matter if I drew this line first and that line next? It's still the same point where they meet, right? So if I'm finding a solution to this, it doesn't matter which order I put them in inside of the matrix, because the way it cancels things out, it doesn't matter anyway. So let's start with this one. So I have a negative 2, 2, and then 1. See that? And my next coordinate will be 2, 3, 1, and 0, 0, 1. And like I said, you could have put this point first, this coordinate first. Doesn't matter. Understood? All right, so let's work this one out. So this would just be 1/2 of, okay, I'm going to do it like you guys would do it now, okay? 1/2 of negative 2. I'm going to get up and use my fingers. Negative 2. Cancel that out, and I have a 3, 1, 0, 1. 3, 1, 0, 1. Okay? Yes. That's how I do it when I'm drawing it out on paper. Then I would have negative, what's the next one? This is a 2. So I'll color 2, 0, 1, 1. 2, 0, 1, 1. Plus the last one, which is green, 2, 3, 0, 0. 2, 3, 0, 0. This one's green, and this one's red. Equals 1/2 bracket negative 2 times 3 times 1 is 3 minus 0 minus 2 times 2 minus 0 plus 1 times 0 minus 0 equals 1/2. 3 minus 0 is 3, so negative 2 times 3 minus 2 times 2 plus 1 times 0 equals 1/2 times, I know you guys think it's silly, but you can make silly errors over being lazy. 1/2 of, and this is where we can be a little lazy, negative 10, which is negative 5. Do you want to write all that out? You can if you want. Is that enough? Can you guys, is that enough for you right there?
Yeah.
Okay. Okay, so what did you learn today? Determinant. How can the determinant of a matrix be used in real life? Finding the area. On your assignment sheet, give an example of a second order and a third order determinant. So basically what we just did, like the A, B, C, D, E, F, that kind of thing. Okay, let me get your stamp sheets back.